A quick review of our journey before we start this tutorial. So far, we have been very much focusing on make migrations, and we've got to the point where we understand the basics of creating a migration, and we are now focusing on custom migration options. I don't want to spend too much time at this point working through different examples, modifying the migration files, because I do want us to get back on track, thinking about actually utilizing and applying migrations and working through rollbacks. Before then, we can iterate around again and think about some more advanced instances where we might want to modify the migration files. There is still a lot of underpinning knowledge to deliver, but let's now focus in on a few exercises modifying migration files. So we're going to start off with building indexes concurrently. I will start to try and bring in a few more whiteboards to make it a little bit more exciting than just looking at a slide. So here we're talking about creating an index in a database. So creating an index in a database can disrupt its normal operation, especially with PostgreSQL, and we will be performing all the exercises with the PostgreSQL database. A quick recap if you're not familiar what an index is in a database. Imagine we have a database table with title, author, and ISBN. So we have this table and let's insert say 500,000 records into this table. The problem here might be that all of these records in this table are stored in no particular order. So when someone wants to query and find a book by, for example, its ISBN number, they may have to start looking from the start or the beginning of the table, the first record, to the end record. It might be the last record in this 500,000 record table. This can be quite time consuming, especially if, in this case, there are quite a lot of records to look through. Potentially, the query that you run on the table would be very slow. Now, let's introduce an index. So think of an index as a separate catalog that will list all of the, let's say, ISBN numbers along with their corresponding location. So along with the corresponding record location in our table. So we create an index for this table based upon the ISBN number. So let's go ahead and create this index. So we would create this index and maybe it would include the ISBN number. So in this case, it's just 1, 2, and 3. And then the location of that record in this database. So let's just call this location 1, 2, and 3. So 1, 2, and 3. So that would then identify the location of where it is. So you might be asking at this point, well, if I had 500,000 ISBN numbers in this index, surely I'm doing the same thing. I have to look through every single record before I get to the record that I'm looking for. So it would potentially be similar to just building the table. Well, database indexes are usually implemented using some sort of structured approach. So for example, B trees or hash tables. So these are two types of techniques that are used to structure an index. So these data structures, B trees, hash tables, are designed to allow for fast searching. So the result of using this structure, B trees or hash tables, for example, means that there will be a reduced number of steps required to find a specific value in the index, which is then obviously then connected to the location of the record in the main table. Indexes such as binary search or B trees, these are organized in hierarchical structures. So the data is organized in a hierarchical structure. So here with this ISBN number, you can imagine ISBN, we might have a tree structure where ISBN number 1 to 1000 is over here. So we only have to make one step to get the ISBN number from 1 to 1000. And then that can be then further separated into 1 to 500 and then 501 to 1000 and so on. So that will then reduce the amount of steps to kind of get closer to the ISBN number that you want to find. So by creating this type of structured approach to finding data, there is going to be less steps to actually get to the data that you're searching for or that you're querying. Don't forget that this tutorial is part of a series of tutorials which you can access on our YouTube playlist, or alternatively, if you would like to, you can purchase the whole course on Udemy. There should be a link to the YouTube playlist and a link to our Udemy course, which should always provide the best price in the video description. So going back to the problem, so creating an index in a database can disrupt its normal operation, especially with PostgreSQL, which typically locks the table being indexed against write operations. So during the index build process with the Postgres database, you won't be able to perform certain transactions such as insertion, deletion, or updating rows. This will all be blocked until the index build is complete. Of course, if you are trying to perform this on a live database, a live production database, this can significantly impact even relatively small tables, which can experience lockouts for periods that are potentially unacceptable in a production environment. For large tables, the index process can extend over many hours. The solution to this problem might be to utilize concurrent indexes, particularly in the context of databases like PostgreSQL. Concurrent indexes refer to the creation of an index without blocking other operations, such as serving requests to the database. So this approach will allow the database to continue handling read and write operations while the index is being created. So in this tutorial, we're going to take a look at modifying migration files building indexes concurrently. If you would like this source code, you can download it from the resources attached to this tutorial. Now here I've mocked up a small Django project. We are using Docker because we're going to be running Postgres database in a Docker container, as well as pgadmin so we can administrate our database, have a look at the indexes once we have created them. Let's first bring up the containers for pgadmin and our Postgres database. So Docker compose up with the D flag, so everything's working in the background. I won't get all the output here on my terminal. And then we go ahead and we will make migrations. Let's just make sure we have no migrations in the migration folder. Okay, so we'll go ahead and make migrations, and then we'll go ahead and migrate. So that's all now added to the database. Determining which field needs an index in our Django model requires analyzing the queries that are frequently executed on our database. So generally, you might want to make an index, for example, where fields are used in where clauses. So if you frequently filter or query your database on a certain field, those fields are good candidates for indexing. Alternatively, you might select a field to index based upon, for example, field used in joins, fields used in order by or group by clauses, potentially if you're using fields in unique constraints or maybe full text search. So there's a whole range of potential reasons why you might create an index. And there isn't really a limit on how many indexes you can create. Now, what we're going to do here is create an index, first of all, for the slug field. So we'll take the Django approach to begin with. Typically, what we're going to do here is create a new class meta and define a new index. We've then defined the field that we want to make an index on. So we've selected the slug field. We've provided a name. So this name is the name of the index. So in this example here, it's going to be product slug IDX. Let's go ahead now and create a new migration. Okay, so we now have the new migration. We can see what's going to happen. So you can see that Django has created an migration.addIndex operation. You can see it's on the model name product, and you can see that we're going to create an index on the field slug. So by default, when you create an index on a field in Django, it does create a B-tree index in the underlying database. So generally the B-tree indexes, these are default index types used by most database systems. That doesn't mean that you can't switch to other indexes. There are many more: hash indexes, GIN, GIST, SPGIST, BRIN, just to name a few there of different type of indexes that you could utilize. And of course, they all have their strengths and weaknesses. And you would then decide on which index to use based upon the data that you're trying to index. So the B-tree index, like I said, is the default. They are well suited for a wide range of query patterns and are the default choice in Django for that particular reason. So we're not going to migrate this. I just wanted to show you the SQL that is generated from this operation. So here I type in manage.py SQL migrate. We were introduced to that previously. It's going to show the SQL related to this migration. We select the inventory app and then the actual migration file, which is 002. So we'll go ahead and have a look at that. You can see what's going to be generated. The SQL that's going to be generated is create index, product slug IDX. That's the name of the index on the inventory product table. Don't forget that Django names the tables based upon the app name and then the class name within our model. So you can see that we're going to create an index here on the slug field. So just as a reminder, so when we create this index without using concurrency, the database typically locks the table against write and performs the entire index build with a single scan of the table. So this means that while the index is being created, other transactions attempting to modify the table, inserts, update, and delete rows will be blocked until the index build is complete. So this is where we start to customize the migration. In this scenario, we don't actually have to write any SQL because Django does provide some tools to specify concurrency option. We're told here that we can utilize the add index concurrency. So we can utilize this operation to actually generate the SQL, which will then generate and supply the Postgres database with the instructions to create the index using concurrency. So we'll go ahead and I'll quickly show you how or what that looks like. Now we are told here that we should be having a look at the documentation so that we're aware of a few different issues, as well as thinking about how we're going to remove concurrency option. Of course, we're always thinking about here when we're building these customizations, we need to make sure that we understand how to actually create the customization, the forward process and the backward process. So that will be very important. So here we're also told that the concurrency option is not supported inside a transaction. So that means that we're going to create a non-atomic migration. So we will need to specify that within our migration file. So just very briefly about this atomic migration. Now, by default, Django's migrations are atomic, which means that each migration operation in the operation list is wrapped within a single database transaction. So if a migration operation fails, Django just automatically rolls back the transaction, ensuring that the database remains in its consistent state before we performed or tried to perform the migration. So we're simply just told here that if we use concurrency, if we use the add index concurrency option, we cannot use that in a typical atomic migration. And so that if an operation were to fail, then we couldn't simply just roll it back in a single operation because we haven't performed the migration as a single migration like we would do normally. So it's probably best if you are going to perform this operation that you create a new migration, an empty migration, and you perform the operation separately from any other migrations. And that would just prevent there being any issues. If there were any issues with the operations and you had to try and roll back, you could potentially be stuck with trying to then have to, in addition to rolling back the previous migration, also have to deal with rolling back the index individually. So let's go ahead and just make a change here. I won't create an empty migration. We'll just utilize this migration file to perform the same operation. If we did delete this and create a new empty migration, literally we would just be presented with this code. So let's go ahead and make the change from this migration add index option to utilizing Django's approach to create the concurrency migration. Now, we could have deleted this migration and create an empty migration, but all we would be presented with is a file that looks exactly the same as this, but obviously without anything in the operations list. So we don't need to make a new operation, a new migration. So let's just go ahead and add the code that we're going to need. So from Django dot contrib dot, we're looking for the Postgres tools operations. So we're going to import the add index concurrency. We are going to need to specify atomic false. So we're going to need to make sure we tell Django that this is not an atomic operation. And then we go ahead and change the operation here. So migrations dot, it's not going to be migration dot anymore, is it? It's going to just be add index concurrently. We specify the model products. That's going to be the same. Index models, index field slugs. Yeah, so everything else is going to be exactly the same. So the difference being, of course, that we're going to apply or create this index concurrently, which means that like I keep saying, the database will still be operational, fully operational. The index will be created in the background, and when ready, it will then be utilized by the database. So let's take a look at the SQL now that's going to be generated. And you can see now the difference being that we're creating the index and then the keyword concurrently. Now we do need to remember here, it's not like building a model and making a change. Django isn't going to be able to detect a change in the database should we not want an index. Remember, this is going to be performed on the database and is then going to be a service, if you like, on the database. So Django isn't going to be able to detect that migration change. So if we do want to remove this, we are told in the documentation, we just need to create a custom migration with the remove index concurrently class. Now you can see by the SQL that's going to be generated by this operation that we've defined here, that the SQL is very simple. And we may prefer in some instances, maybe when we want more finer control of what we're doing, we might just choose to use SQL. We might just ignore this built-in operation and just go straight to the SQL. And of course we can do that. So let's make that change. So let me just show you the operation for this. So I'll create a new operation list here and we'll just comment that out. So I make this change. So here we would need to run manage dot, like we learned in the previous tutorial, SQL. This needs to be migration, migrations dot run SQL. And then we simply just need to run the SQL. So we know that's very simple at this point. So SQL equals, let's go for create index we're just really just copying out what is already there in front of us. So concurrently, and then we need to specify we're going to specify the product slug IDX. So that's going to be the name of our index. And let's just make sure that we have correctly defined that. So the doubles. And then we're going to say on, and then we need to define the table. So we just need to be careful here to remember, like I said, that how the tables are named in Django. So Django names the tables with the app name and then the field name. And then we need to define the field. So that's going to be slug. Okay, so let's just make sure we finish that. Semicolon. And then we're going to need a comma because we can then define the reverse. So for the reverse, let's go ahead and say reverse SQL. And we'll go ahead and specify drop index. And then we just need to then specify the name of the index, which is the product underscore slug index. And there we go. Okay, so we need a comma. Let's make sure we've got the comma and then the closing parentheses. And I think we're ready to go. Apologies, I get myself into some useless situations demonstrating the code on screen. Hopefully you can clearly see that what we have just created. Right, so let's go ahead now and actually migrate this. So we don't need to do a migration at this point, make migrations. We just need to migrate this. So let's go ahead and migrate and give it a go. So it has been now applied to the database. So I did create a PG admin container. So I accessed that through 127.0.0.1:5050. That's the port number I've opened up. So the email address, you can see the details of that in the compose file. It's a@a.com. That's the login details. The password is Postgres. And you can then go ahead and log in. So once we've logged in, we just need to quickly add a new server. So the server name is going to be Postgres. That's the name of that's the name we're going to give it. And then the connection details, so the host name. So that's the name of the service that we've described in our Docker Compose file, Postgres. You can call it whatever you like, of course, but I've called it Postgres. That's the name of the service. So I use that as the host name. This is the default port. The username is going to be Postgres. The password is Postgres. Let's press save and we've connected. Right, so we go into a database. This is our database, example DB. And inside of here, we have our schema. So we'll be able to find the tables. So inside of there, we have tables. And then inside of there, we have the inventory product table. So I can have a look at this and then view the indexes. So we should have a new index. And there it is, product slug index. Let's see if we can take a look at what we've generated. We have a definition. You can see it's a B tree index. There isn't really too much else there to look at, but we can see the basics of that. Now, something you may notice is that we have all these other indexes and we haven't actually specified them, or it doesn't look like within our model that we have specified these indexes. So you might not have known that in Django, when we make a migration, Django will automatically create indexes for fields that are foreign keys or have unique constraints. So this is specific to PostgreSQL databases. I'm not too sure about MySQL databases, but definitely in a Postgres database, Django will automatically create these indexes. So Django will try to automatically create an index on any of your foreign key constraints or unique constraints, particularly where you may have defined a field with the unique true. So here you can see that we have category ID, which is a foreign key in this table. We have a seasonal event because in this table, there is a foreign key to the seasonal event table. And in addition to that, you can see there is an index for product name. So you won't be surprised now to find that if you go into the model and you take a look at the name, we've defined unique equals true. And that is why an index has been created by default for that. Now, what you can do, because we now know about the SQL migrate command, we can actually take a closer look at the migration, the first initial migration. So if I go ahead and do that, so SQL migrate the inventory app and then the name of the migration, if I run that command and we take a look, you will find we have created a number of different indexes. So that isn't necessarily very clear, or it isn't defined anywhere else within our models, but it is being created automatically. So let's take a look to see if the actual reverse SQL will work as well in this instance. So what we want to do here is just roll back slightly. Now, we haven't actually covered rollback officially yet in this module. We will do shortly, but I think it's quite a useful exercise just to roll this back to see if this works. For that, what we can do is the manage.py and then migrate. And then let's go back to our app name, which is inventory. And then we just need to use the name of the previous migration. Give that a go. So it looks like everything has been unapplied, or it looks like it's tried to unapply that. So let's take a look. So if I get back in PG admin, I just refreshed the table and you can see that now has been removed. So hopefully you can start to see how you can utilize migrations, and that was an instance where potentially a custom migration would be beneficial to create. And we saw an example there of having that choice between using Django or using SQL. And it looks like in this particular operation that using SQL is probably a lot easier. And definitely in terms of migrating and then rolling back, it can be a little bit more, potentially more convenient to just run your SQL. And you can start to see hopefully how you're using SQL. And obviously you can be or have a little bit more control over exactly what you're doing. If you can imagine this was something a little bit more complex, imagine Postgres database did have some other options that we could include here. Well, that is obviously something that Django wouldn't be able to support. So a custom migration would be more suitable in that case.